Hello and a warm welcome to my talk about automated database deployments in modern DevOps processes. My name is Mark Müller. I'm a consultant at Fortecture in Switzerland. I'm a Microsoft MVP for Azure DevOps, and we're consulting companies all around DevOps in the Microsoft stack as well as enterprise application development and architecture. So what's up for today? So it's all about how to bring your database development, your database schema changes within your development lifecycle, within your DevOps process. So we got a quick intro into the topic, then move over to SQL Server Data Tools, have a look on how we integrate it into release pipelines, have some details about migration scripts and some practical examples. So without further ado, let's start. So where are we usually? In general, if we talk about a DevOps process, the faster we provide value to the customer, the better it is. So a long running process where a customer needs to wait weeks or months for bug fixes and new features doesn't make them happy at all. Very simplified, a modern DevOps process should provide the value to the customer side quite quickly with the right quality. So all in all, we need to improve the overall process to be able to provide value to the customer in a good, timely manner with the right quality. So how do we do that? Or what the overall target? If you're in a workshop, we always try to bring up the following statement: 100 deployments a day. If our DevOps pipeline is ready to fulfill 100 deployments a day, we have a fully automated, integrated DevOps pipeline in our company, and that's the way to go. We don't do that by just writing faster or do more stuff manually. It's all about automation. So ready for running 100 deployments a day means we have a fully automated process. So we have build automation, deployment automation, as well as test automation in place. Ideally, we have a fully blown pull request deployment as well, that we can isolate each change, deploy it to a near production environment, have a full test coverage there, and then integrate the code and have a good quality gate around our code with a pull request workflow. Furthermore, we would like to have those frequent small releases. The bigger the release gets, the more feature we combine. It's harder to test, it's harder to get to the root cause of an issue, and last but not least, also mentally, I'm still far away from the development if I got a bug weeks or months later. So I would like to have small frequent release ideally as a pull request release, as we already talked about, to reduce the complexity and have isolated changes throughout the process. And well, lastly, there is no place like production. So we always try to have a fully blown process, even if we just test a pull request deployment, that it is more or less production-like, that there is no difference, nothing else could go wrong when we finally integrate and deploy application. So what about the database development then? Well, database development is usually always fully integrated. We have no manual schema changes, and automated deployment of schema changes is on a daily basis. Well, based on our experience, the reality doesn't look that great, or there is some room for improvement in regards of database development or the integration of the database development into our process. So usually we often have different teams, that there is like a database team, a development team, etc. The development is not integrated, that code changes for a particular feature is not necessarily maintained in the same feature branch as the code. It could be done manually, etc., etc. And a very worst case is that we have some schema mismatches between development database and production database. And this is really a situation we cannot have in a modern process. And today we would like to have a look at it on how to not get into this bad situation, or if we are in this bad situation, how to get out of it. So to do that, we need to face a couple of challenges. So first of all, the most important thing is that schema of the database and the code change, they belong together. Or in other words, treat your database as code. As if you write C# code, for example, you would develop your database schema changes within your source control, for example, inside your Git repository. The application change and the corresponding schema change belong into the same feature branch, into the same pull request, and will be shipped together. This is the overall goal. Then we also need to be able to do a dry run on maybe production data or test data, which is very near to the production data. There are often complex situations for data migrations, so that we can't just deal with a simple, well, add a column to the table. Maybe we need to execute some business logic, how to transform data according to our changes. We need to set some reference data in the database that we need to update, for example, labels, messages, etc., together with a new feature development. And last but not least, we often need a zero downtime deployment. So in modern cases, with modern applications, cloud-native applications, there is no planned downtime, especially if you want to do 100 deployments a day. We are constantly deploying towards our services, and we do not have a maintenance window or update window included. So, long story short, we need to treat our database as code. So, we need some tooling for sure. Today, we will have a look at SQL Server Data Tools, SSDT. This is a tooling developed by Microsoft for SQL Server. So it helps you develop your database to maintain a database schema within your code. It's fully integrated into Visual Studio, but it's not the only tool. Today, I will demonstrate the whole process together with SSDT and Visual Studio, but there are other great tools on the market, like tools from Redgate, etc., open source tools. They all have more or less the same goals. Some do it a little bit better, some not, and we will point out why I really like SSDT. So SSDT has several advantages. It is fully integrated into the IDE, Visual Studio. It integrates into MS Build, which means that if I'm compiling my project, I'm compiling the database project as well, which means that it does perform type check and consistency check. So it's not just a bunch of strings lying around in SQL files. It really validates the whole database if anything is wrong, if something does not match. So I have a build time validation, which is really useful to detect some issues very early, even locally during development. We have full IntelliSense and validation support out of it. Then we have it in the code base. So we will see later in the demo that each database object is stored as a SQL file on disk in Git. It's really treating the database as code, exactly what we would like to have. So we can also easily merge those code files together if multiple, for example, multiple feature branches modify the same table. Then we can use a design and compare functionality. So in order to check some change of the development database or have some DBA specialist working on some performance optimization, we can easily compare those changes and convert it back from code or publish the code changes towards a database, a development database, or later on in the CI/CD process to the target database. Yeah, this is the last point. We can easily integrate it in CI/CD automation, so continuous integration to build up this schema definition file, and in the continuous deployment, we can deploy it to our target database in our process. So, sounds really good. It is good. It's free. It's there. It's there since 2015. We have a one-by-one database representation in our code in Visual Studio or in our tools we like to use. So It consists of the DB schema migration. We have some hook points as well. So during this DB schema migration, we can hook in with custom scripts. This is important because we often have the situation where we need to add some custom business logic to convert the data, to create new records, to move records together, to separate records, and so on. And last but not least, also, we can easily integrate it in our tooling. There is a NuGet package, there is an SDK, so whenever I need a custom deployment tool or a custom CLI tooling, I can easily just grab the NuGet and integrate it into my application. So all in all, what features do we use? We have build-time validation, we have a great editor in Visual Studio, we can visually design our database as well as in the SQL files by text only. We have this bidirectional scheme comparison from the SSDT project to a database and from the database to our project, so we can easily convert code written by DBA in a development database to our file structure in Git. And we create a so-called DAGPAC file. A DAGPAC file is more or less a desired state definition of our database. So we are not directly in our build process generating a migration script. We are generating a description of how the database should look like. Then during deployment, we are comparing this desired state towards a target database and generating a migration script on the fly. And this has a lot of advantages since I really do not need to check in theory what version I've got. I just get a script out of the diff between my desired state in the DAGPAC, it's a data access component package, between the desired state in my package and the target database. And the really cool thing, since it's a dedicated file for each database object, I can very easily integrate it into my Git repository. I have the change tracking, and since it's text only what's lying there, I'm also able to merge changes together as we would do in code. So having multiple parallel feature branches open is no problem at all. We can do the merge process as we're used to from the coding part. Schema compare basically compares two sides, either the SSDT project and the database in both direction. We got a differ. I can check which change should be applied in which direction, and it's really easy to also grab a feature branch and just deploy those changes to my local development database, work with it, and then push the update back again to the shared repository. Then there are some other benefits. As I already told you, there is like compilation support. It integrates into the MS build process. So if I compile my solution, I'm building this project. I have a lot of code analysis available for my database project, so I can really make sure while compiling locally everything is okay. So without further ado, let's have a look and start into the first demo where we have a general look at SSDT in Visual Studio. So in this demo, I would like to provide you a sneak peek into SQL Server Data Tools, SSDT. I've got my demo solution opened. It's an application which has a backend service and a front-end web application, and it just presents you developer jokes. So in this demo, we are particularly interested in the backend side, in the database scheme. As you can see, I've got my solution, I've got this database project already open, and now we would like to create a new feature or change the database. So first of all, I'll quickly create the feature branch. Let's call that feature DB demo. And now I need to have a local development database. So usually I use Docker for that. I already started it, but I just ran a Docker prompt starting SQL Server in this version 2022. And so I'm able to develop locally with a local application. I'm also connected in my management studio here. As we can see here, I've got my dev farm database. I can quickly refresh that, and I already got some existing tables in it. We could also create the database from scratch directly from Visual Studio. So let's assume we would like to extend our chokes table. I can double click here. Actually, it's a SQL file. We got the content down below here, but I also get from the tooling a beautiful editor. So let's assume we do add a dislike count, and it should be an integer. Let's keep it nullable for simplicity. I'm changing that. And what we're able to do is now we can say, well, I need to run that in my database. And for development reasons, I could just say, well, let's do a schema compare, or we could also a full publish. So let's select the target here, choose the database. Let's take def one here. And let's compare that. So we see our table. There is a column added, and we just deploy that to our database. So now the schema compare is running, updating the database. We have a green status down here, and now the database is updated, and we should be able to see that if we quickly refresh the database, go to dev chokes, check for the columns, and here we have a dislike count. The cool thing about this tooling is that it goes into two directions. So if you have a DBA working directly with the database, and yeah, well, basically is he's not using the editor, maybe he's writing some really expert level SQL scripts, it doesn't matter. So you can directly work on the database as well. Let's put here like a flag inappropriate, and let's put that as a, no, not a big int, as a bit. Let's save that. And so let's assume we have very complex database optimizations going on a development database, and we can have a bidirectional sync here. So we just change the tooling and do, and again, a compare. And now we see the changes from the database. So there is this new column coming directly from the database. And now if I hit update, it is actually updating my code bases. So let's do that. It's running. And now we should see our changes in Git. And we see now that we have changes. We have the dislike count and the inappropriate flag of our chokes table. So this is the overall workflow. We treat the database as code. Inside our solution, we have Git to track the changes. We can easily work on feature branches. We can merge the SQL files together. What you see here is an editor, but really in the file, the content of the file is the SQL script here down below. So what else do we need to know about it? So this tooling is really good in Visual Studio, but nowadays we are building a lot of applications running in Linux containers, etc. And I've got this Visual Studio tooling with me. So the downside of it, it needs Visual Studio, it needs Windows dependencies. So actually this project over here, this stepfun.db, is not ideal for container development if I would like to compile it in a Linux environment directly in a Linux container build. So there is an easy trick to do so. I've added another project here, and this just states the SDK to SQL project. So this SDK actually is cross-platform compliant. So what I do here is I'm just linking all the folders. So it's basically a clone of everything I did. It just references the file from the real SSDT project, but now I've got a project type which is compilable in Linux in a container, so I can use it everywhere I need, but still have the fancy editors in Visual Studio. Furthermore, there is not only the SQL objects we can just track here as the files, as you have seen, like I've got the tables here. We can also use some hook points actually in SSDT to have some custom scripts. Often you need to have some business logic for data migration, add a couple of things. And what we did is we have so-called PostScript, pre-script, and reference data script. So here we could have some arbitrary logic, like this is an update when we introduce categories to already pre-match chokes to a specific category. So I just add the script file in here together with the hook point, and once it gets deployed, we have everything in there with our custom logic as well. So now, as a quick recap of what we have seen here, a little simplified developer workflow based on the SSDT tooling. So we've got our Git repository, we have our Visual Studio project, and a local development DB, as we have seen. So first of all, I'm creating a branch, checking out a branch from my Git repository, my feature branch. Then usually I'm using a publish feature, a deploy feature. You can do that by right-click publish or hit F5 if it's configured as a startup project. Why in general not a schema compare? Well, the advantage of publishing is that it's not only comparing the schema, but it also executes all your custom script logic as well. So if you need to get your local development database to the right state, usually you do a publish or a deploy of your database project. Then you're starting developing, do some database changes as you have seen in the database directly, or in Visual Studio, you have this bidirectional sync. And once you've finished, we compare everything, we update our source code file, our SQL files, and last but not least, we commit, we publish the feature branch, create a PR, review it, and perhaps it goes directly in, or we can redo the whole process over and over. So we can again grab the latest state, do some further changes, and then publish it again to our pull request. So this is the overall developer workflow locally. So let's move on with custom migration scripts. So SSDT, as we have seen, is a great tool to easily add tables, add columns, redefine columns, etc. But it has some limitations. So the problem mainly is the limitation towards custom logic. So it offers a single pre-script and a single post-script hook point. So I can simply have a single file which is executed before and a single file which is executed after the database schema migration. And this is often hard to maintain in an enterprise level scenario where we have multiples, hundreds of scripts from different teams which need to be executed in the right order. We need to keep track of which script needs to run on which version of the database. If it's already been executed, maybe it shouldn't be executed again, or I need to have some logic inside the script. So usually in an enterprise scenario, it can get very complex. So it would be great if we could extend that. And usually we do so by maintaining a lot of scripts within our source code and having some glue code, since we still just have two hook points, pre and post hook points, to have some glue code in between which script needs to be executed when. We also need some state tracking of custom migrations, that we keep track of which script have been executed, that we can guarantee, for example, that a script can only be executed once and not multiple times. And usually it's also worth having some database version tracking, like a history table within the database to do so. And well, is now SSDT not the right tool for us? No, it's still a very good tool to accomplish our tasks, and it can be easily extended. So what we can do is we can build up our own logic for migration script. We separate the files that we are able to really focus on the content of this particular single script and have some management logic around it, when to execute and how to trace it. So we also do want to have an automatic migration management to check what has been migrated, what database version we have, and we want to have those managed pre and post scripts. There is also an addition to pre and post script. Often in larger database, we often call this reference data, like you have messages in the database, you have maybe combo box values in the database, some have some translations in the database as well, and we need to manage that as well because it could also be related to a feature change that we need more data, that new tables, columns with drop-down values, etc. are needed, or it could also be a subject to change in the development of our application. And well, we need error and transaction handling for that as well. So the more complex our logic gets, the more control we need how to roll back certain scripts, etc. Okay, so let's do that. How could that be done? In this deployment process flow, we have those hook points. And what we do is we use these 2 hook points to inject our custom script logic. So we build the whole deployment script, and during the database deployment, there's the hook point executed for the pre-deployment. Then the schema migration, this is fully automatically done by SSDT. And then we need to run our post script. And here we have a separation between the reference data deployment scripts and the post deployment scripts. So how could this look like? In our code, we could have a dedicated script folder, as we can see on the top right, and have different folders in it for different scripts. And here we used some sorting with timestamps, that we have a timed ordering of our scripts, that they are executed in order. You could do that with timestamps. You could just do that with some integer values counting up. And then we need to reference that. So as you can see down here, let me quickly grab the laser pointer. We have such generated script. So all in all, we want to manage those small scripts in our solution. But then since we only have those 2 hook points, we need to generate the overall script with a lot of logic, which checks the database version, the run, if it has been already run, etc., etc. So we do that by injecting our custom logic into the MS Build project, and then it's basically our logic which gets executed. And we can do that very easily. So another thing we usually need to do is to keep such kind of a migration script history. And this is done, in our case, we just write every script which has been executed together with the hash value of the script into a history database table, so we can easily see if a script has been executed already, if it should be executed only once, or if it can be executed multiple times. This is then our logic in the SSDT extensions. So if you're interested in how you could extend this logic to your needs, there's an open source project we created a couple of years ago, and it's still used in many projects, how you could manage your extensive script logic with your own logic, with your management of different script files, because we just learned that out-of-the-box migration is often not enough. So let's move on to those migration scenarios. We have different scenarios usually if we deal with database schema management, and a lot of them are covered by the tool. Let's move on to this overview, and we have this green column in the middle where we see the out-of-the-box support. So adding fields, change nullable to not nullable, delete the field, etc. So we have a lot of support by the engine itself. So for most cases, 90–95%, the SSDT should just work as expected. But if we deal with data changes, maybe there is some action needed where we need our custom scripts. And here we see with the blue boxes where we see potential extension, because SSDT can just do the bare technical migration, but doesn't know anything about the data. So there is still some need to put in your custom scripts into the solution. Regarding the reference data, again, like fill out drop-down fields in your applications, provide values, etc. We often use those merge queries, where we just check if the value is there, if it has changed, and we update it. If not, if it needs to be deleted, etc. So we have a lot, usually in larger applications where we need to deal with such kind of reference data. We have a lot of merge queries, as you can see on the right, ready to run, that we also have this concept of a desired state of the data, and we just adjust the entries of a table to our desired state of our project, which is again a custom script extension, just running all those merge queries to the target database after the migration, the technical schema migration has been performed. Okay, so now enough about the tooling. We've seen that it is a very valid tool, fully integrated into the Microsoft technology chain. One drawback there is, well, it's only working for SQL Server. If you have other database platforms, you need to use a different tool from a different manufacturer. But again, there are great tools out there. The concept is more or less the same. There are little differences between the tools of other vendors. I personally would choose a tool where you still have this possibility to have some type checks, some validation, and that you don't treat your database scheme as a bunch of string objects, etc., which never get validated before you actually deploy them to the target database. But now let's move on to the actual DevOps process. So we need to integrate that thing. So until now, we just had a look at the tooling, how to work with that locally, and now we need to move on and put that into our DevOps process. So the challenges here is downtime. Downtime is always a really challenging thing. In theory, we can just run our database migration with our SSDT tooling, with our DAG pack towards the database during runtime. So there is no need to shut down services. But there is a small but. The tools usually create, for structural changes of tables, they create sequential transactions. So the problem now is that if we need to heavily change a table which is quite large, and this change has to be performed in a sequential transaction to have the full control about this schema change, well, all the other transactions will be coming later on. So basically, if moving that table to a new schema takes a minute, all other database requests will just queue on and wait. So you could still actually have some downtime issues if your schema deployment is locking or using sequential transaction, which just take too long because you're really transforming huge table. So it's not a thing you can say, well, I'm using that tooling, it always works. You still have to pay attention what changes you would like to perform on your production database, and if there is not a more simpler way which doesn't require a sequential transaction which runs for a very long time. Then we need to think about rolling forward and rolling backward. So what should we do if something goes still wrong with all the things we did with pull request, deployment, verification, test automation? There could still be an issue when deploying to production, and what do we do then? The planning I mentioned with the downtime. So if we plan bad, there is a probability to face a downtime since our transaction is just taking too long. So we need to think about what changes should be allowed, and also what breaking changes should we allow in the system. So often a simpler changing model is the good way to go, that we usually try to avoid breaking changes, that we work a lot with mocking things like that we still have, instead of triggers, views, mocking old structures, that we are able to just continuously run our application, and then in a couple of releases time, we are going to actively remove tables or columns from the database scheme that we do not have the breaking changes at first hand in our first deployment. Then, in addition, we need to think about DB first or code first deployment. We will cover that in a second, and also about handling multiple schema versions. So the DevOps process integration is really straightforward. We just build the whole thing within our CI and then deploy it in our CD pipeline. And the tooling is there. We can just compile and deploy the whole thing and deploy it towards our target database. So the Visual Studio integration we've seen, we basically design, validate, build and deploy locally, but what we have now in the source code are those SQL files. So what we need to do in the pipeline integration, we just need to build it from those files and then deploy through the deployment pipeline. So all in all, it could look like something like this. So first the CI build compiles the application, but compiles the DAG pack, the database structure, in addition. We also can see on the right-hand side that I'm producing artifacts. So here we see pipeline artifacts of Azure DevOps, and we not only see the DLLs, the application, the Dev API, we particularly see a DAG packs folder containing the DAG packs. So not only the code of our application and database belongs together, but also the build artifacts. There is one build I created artifact in version 1.2.3, and I'm providing you the application with that version and the schema with that version. And as we can see, we are publishing the DAG pack files from our CI build. So now, how do we do the deployment actually? Well, there are two options we could take in the deployment. One is called database first, and it looks like this. So we currently have version 1 deployed, and we would like to release version 2. So in DB first, we first update the database to version 2, and the application is still running in version 1. Then in a second step, we deploy the binaries. So we update the binaries, our application, to version 2, which means that our version 1 binaries still need to be able to work with an updated database. This means that we can't do breaking changes, that if we actually remove a database table, we would use a view, and then instead of triggers, that the old application code could still just run if the database hasn't been changed, and then remove those changes later on in one of the next releases. On the other hand, there is also a code first approach, which means exactly the opposite. So we deploy the binaries first. So the database is still in version 1. We deploy then the binaries. So here we see we have like a factory, some module loading, feature flagging, etc. We basically check the database version, and then we use either this module or this module, or this copart or this copart. So it's we have way more things to do in our application this way to be able to just run the database deployment in a zero downtime scenario. Both of those approaches work with zero downtime. It's basically the decision where we need to put the fallback logic for the old version, for the old component in. And well, let's compare that as well. So if we do a database first deployment, we need to have the fallback logic in the database. This means we just use views, triggers, etc. to support or mimic the old schema, that the old application code can still work. So the advantage is, well, our application code is way easier to maintain. And if we think about not having really big changes in the database, that we limit the changes a little bit from our planning point of view, it's a lot easier to just develop your new version of the binaries and make sure that you don't have a lot of breaking changes. And if there is one, you just mock it or mimic it. Yeah. Then this is just harder to test, actually. So the easier it is on the development side, the harder it is on test. If you need to write unit tests for your database code, etc., it's a lot easier in the code. So on the other hand, if you do the code first approach, if you have a factory pattern, we load one or the other version, we just check the database version and then use one code part or the other. It's a lot easier to test, but the overall process is a lot more complex. So all in all, I would say 80% of our customer base is using the database first approach because it's just the easier way to go. It doesn't overcomplicate your actual development of your application, and based on experience, you usually or hopefully with a decent planning, you don't change your database scheme that much. Usually it's a lot of additions to your database which happen throughout the life cycle of your application, and therefore usually we recommend to go with the database first approach. So next thing, rollback scenarios. So there could be a situation where anything goes wrong in our deployment, and what should we do now? I really like this statement of Buck Hodges, who was a technical lead in Azure DevOps development. And he once wrote a blog post and told everyone, if you can't get upgrade right, what leads you to believe you could get a rollback right as well? And he's so true. I mean, you spend a lot of money, a lot of effort developing all the rollback scenario you probably never use. And if you use them, there are a lot of things which could go wrong. So there is a huge testing effort. So usually it's easier to just go forward. If you have set up a proper DevOps process with a lot of automations, usually just go forward and do some fixes is the easier and simpler way. And also with the database first approach, well, if something goes wrong, it's still in the old version, or your changes are rolled back, your application is still running in the last version. So usually, even if a database deployment goes wrong, your customers won't really notice it and you have time to fix it, and therefore roll forward with a new update is often the easier way to do so. Okay, so how do our CI/CD pipelines look like? Well, the CI is producing the artifacts, the application, as well as the DAG pack, and the CD pipeline is just deploying it to multiple stages. What we can see here, usually we have a different or a fork in our continuous deployment pipeline where we separate pull request deployment versus the production deployment. Why that? Well, in pull request deployment, you usually set up a new database from scratch. You need to initialize your database with some test data because you want to run some system integration tests or system tests on it. So there is a slightly different flow. The actual deployment is exactly the same, but in a pull request deployment, you need to, for example, create a new database, set up the security and permissions, and then initialize the whole thing. On the way towards production, why do we have here three stages? Well, usually you have still some integration testing stage. You want to run some tests before it really goes to production. And in between, we have this pre-production. This is a thing we could use to clone a production DB, because actually we never test on production DBs locally because we have problems with data. We need to have an anonymized software to get rid of all the personal data. Usually production databases are really, really large and you don't want to distribute that over and over. And therefore, in most teams, we have a smaller database to test. But the only thing which could then fail during the database deployment is really working on this large database, which has a history of 5 or 10 years or so. So what we could do, and it's really an optional step, is have a pre-production stage in between where we efficiently clone the production database, deploy the schema to that clone, make really sure nothing could go wrong, and only if that was successful, we move on to the production deployment. So, how do we actually deploy the whole thing? Well, it's pretty easy. We need this SQL package executable. So it's a single executable. Again, there's also a NuGet available if you want to implement your own tooling. I'll show you that in a second. And we just need to call it. We just say SQL package publish and then have some parameters, and here we go, and the target database will be updated. So again, let's have a look how we do that in our demo application. And yeah, let's start. In this demo, I would like to show you how to bring the whole SSDT packaging, the DAG pack, into your CI/CD pipeline automation. We already know our project structure with the DevOps, the SSDT project in Visual Studio. We also learned that there is a dedicated build project to have a cross-platform build. And since I'm using Docker containers as a build environment and runtime environment, I need to use this cross-platform build project to be able to compile the DAG pack in a Linux container. So down here, we've got our DevOps API project, which is a web API which relies on that database. And I've got a Docker file definition. So inside this Docker file, I've got a dedicated stage for building the DAG pack. So first of all, I'm building the application and so on. And it's a simple one-liner. So it's a .NET build for this build project, this SSDT build project I just created in release mode. And I'm providing the DAG packs to the /DAGpack folder. So it's a simple .NET build command since it's integrating in MS Build with its own SDK. So if I'm doing that in a container build, how do I get it out? So there's a little trick I'm using here. So I have multiple stages, and here I have a DAG pack stage, and I'm also setting a label with DAG pack equals the build ID. So in my CI process, when I'm building the whole thing, generating the container image, since I would like to export the DAG pack files, I can easily go there after the Docker build finished, get the ID of the intermediate image by using this label filter I just used while compiling. Then I'm quickly instantiating this container by the ID. I copy the DAG packs out of the container and just publish them as pipeline artifacts. So what about the continuous deployment? So in my continuous deployment pipeline, I've got over here, before deploying the application, I'm just deploying the DAG pack, the schema to the target database. So I also created a simple template here, SQL_deploy DAG pack. And if you have a quick look at this one, it's also a simple one-liner actually. So we've got our DAG pack file, which contains the full database schema. I extracted it from compilation, provided as a pipeline artifact, so the CI pipeline can provide it to the CD pipeline. And inside the CD pipeline, I'm just grabbing this DAG pack file and I'm calling SQL package publish. So I made sure that inside my agent, I installed SQL package, or if I'm using worker container jobs, I'm just installing SQL package inside this worker container. And then basically we just need to publish this DAG pack towards target database. So we have a connection string. We're providing all parameterized in this template. And we also provide a couple of configuration options for DAG packs. So here we have an option block on possible data loss that I could prevent losing data, for example, if a table is deleted, etc. We can activate smart defaults and so on and so on. So I've got a set here I usually use for deployment. I can still use this parameter block on possible data loss to decide outside of the template if I want to allow that or not. Yeah, and that's it. So it's a very simple way to integrate it. We just need to compile a project to get the artifact, and then use SQL package to deploy that artifact towards our target database. So let's quickly talk about the security consideration towards our deployment. So if we integrate the whole thing, the database schema deployment, in our CI/CD pipeline, we also need to think about security. So first of all, often we should use dedicated deployment agents. Why? Those deployment agents will have access to production databases, to production servers, etc. And it doesn't make sense that you have this single agent somewhere running, which has access to everything, and you have hole punching from the outside to the inside. So it is very important to have dedicated agents, and the agents, they should live near the target environment, ideally behind the firewall, directly on the machine, because the agents of Azure DevOps for Azure pipelines, they always connect from the agent to Azure DevOps. So there is no hole punching needed because we initiate the connectivity from inside to the outside. Then we need a very strict security boundary between dev, test, and prod. So not only those agents should be near that, no matter what, an agent using production credentials does not live as well in the dev test and could be used for other workflows, and they could have or gain some access. Then another thing we often see is we need dedicated user for each database, each service, and also we need a dedicated user for the whole schema deployment and the application at runtime. So let's assume we have two backend services, both accessing their own database. We actually end up with 4 users. We have a runtime user for each service, and each service user can only access its database, so that we do not have a single user accessing all the database. We also enforce that security that only the user has access to the dedicated database. But during deployment, as we have seen, we do the database schema deployment. It needs far more rights. This needs to be done with a dedicated user. So for each application, you have the runtime user to read-write data, and we have a deployment user which has more privileges, creating tables, deleting tables, and so on and so on. So we need a dedicated user with DDL permissions, and the application user, it should just have read-write permissions on the database. Then let's put some words on containers. You already see that I'm using a lot of containers. I run my application with containers, and basically we can use them in development as well. So the local development is a lot easier if you need to deal with databases, etc., to just run them inside the containers. But also, if you need to test multiple databases, it's easier to just spin up different containers, different database versions, instead of installing them locally. Then for testing, you can easily integrate the database baseline into a container, which means instead of running or using the database which is stored on the volume outside of the container, for testing we could have the database inside the container, which means that if we create a new baseline, a new commit of the container, we just have this data ready, and we can easily revert to that data as well. And this really speeds up your testing if you just need to start a container and you have an initial set of data in it. And also we can use the container for database schema deployment. So instead of installing SQL package, etc., we could build up a container which has all the tools in it and is used or executed once during deployment, and we have everything inside this container. So currently, if we deal with SQL Server, we have Linux containers available for the last 3 versions. You can just grab them and execute it. It's very fast. It's a single line Docker run. You accept the EULA, set an initial password, define the ports, maybe do some volume mapping to store the databases, and you're good to go. If you need to test multiple databases, we often do that if we really have a product needing the validation that it still runs across multiple database versions, we could also do that in the CI/CD pipeline. So as you can see on the right, we're just spinning up we're just spinning up container jobs within Azure pipelines, and here we can use service containers. And I could load multiple of those service containers. I could also use matrix builds to run different tests against different backends, and it's so easy to just reference the right container image, and we could directly integrate it into our pipeline, and even could do so as a shift left within the CI build to have some first integration tests with different database versions if needed. So how does the baselining work for local tests or also for some integration tests in our pipelines? Well, it's pretty straightforward. You spin up your Docker container, as we can see in the first picture on the right-hand side, and you just have your database up and running. You deploy your schema, insert some test data, whatever you need to do to have this initial baseline. So once we have all the data to start testing inside this SQL Server container, then we just perform a Docker commit, which means we take a new snapshot with all the data in this container. So we tag that, as we can see here. Let me quickly get the laser pointer. We tag that, for example, with a version 001. And always, if we run that Docker container, it has this initial set of data, and we can easily reset the whole database with just a restart of the Docker container. So as you can see here down below, if we want to do that for testing, we just do a Docker run, and we just use our tag, in this case our version 001, and within seconds we have a database server up and running with the exact state of the database we need for testing. And then, well, we could use containers for our DB schema deployment. So instead of deploying the SQL packager to our agent, etc., we could just build it into a container, or we could also build our custom CLI around it if we need to execute some further business logic. So how do we do that? So actually we could build a worker container and just install SQL package to it, and then use this worker container in a pipeline to run our toolings. Another thing is we could build up a CLI. So we could write C# code, as we see here, using this NuGet package, add some custom business logic to it. So basically we have the SQL packager exe as a NuGet package. We build around our own application, our command line application, create a Docker image out of it, and then just use it in deployment where we just run the container. So having this ready leads us to the situation that we could use autonomous deployment or self-contained deployment. So until now we've seen that we just need to actively run SQL packager within our deployment automation, but we could also use a self-contained package. One way to do that, for example, if you use Kubernetes, is to package your SQL packager container inside your, for example, Helm deployment, and use that one as a job to initialize, to deploy the database before the actual containers get started. So how could we do that? It's about shifting this database deployment logic from the pipeline towards the application package. So we move basically just the CI/CD logic towards this application package and execute it, and have a much more simplified CI/CD pipeline. So how does this work? Let's have a look at a potential Helm release we're doing. So we have our database and we would like to deploy our application via Helm package in Kubernetes. So to do so, we have a deployment. The deployment creates our pods, and inside our pod, we have our application container. So what we've learned from our pipeline approach for executing SQL package, we need to update the database up front. So let's assume we have a database first approach. We need to update the database. So this container shouldn't start or shouldn't be updated before the database schema deployment actually happened. So what we do is we add another init container to the pod, which is basically just blocking our application container from being updated or from being deployed. So then we start a job in Kubernetes with our migration logic. So this could be our container, which is created with a custom CLI or just with SQL packager in it, and it runs once. So it doesn't matter how many instances of our application container we have, how many pods we have, there is a single job running doing the database migration. So what our init container is doing actually, it's just listening or waiting for the job to succeed, to finish successfully. If it's not finished, this init container is still running, blocking our application container. So the job updates our database. Once finished, the job succeeds, it's finished. And so our init container knows about it and also finishes executing. And then our application container is up and running or will be deployed. And then the application container can run or can access the database. So as we can see, it's just shifting this deployment logic from our actual pipeline into a system like Kubernetes where we can play around with job and init container. So all in all, we need this artifact, this executable artifact with the schema definition to be executed in our target environment. And the more we can push it towards the target environment, the better it is. If not, we can still use pipeline automation to do so. So let's have a look how this looks like in a Kubernetes deployment. So here we have an existing deployment. We perform an update. So a new job is created. We see here it is blocking with the init container. So the new version is being blocked. The job now succeeded, which gives a go for the upgrade. So now the init container is still querying the job state, and as soon as the job gives a positive feedback, which is now happening, we are updating our new application pods and then do, in this case, a rolling update. So even without a fully blown logic in the CD pipeline, we can achieve this mechanism of publishing our DB schema before the application deployment, all contained within a single Helm release. So let's quickly sum up as a short recap. So first of all, the database development needs to be fully integrated into the development process, or in other words, treat your database as code, use appropriate tooling like SSDT for that case. There should never be a manual schema change in the deployment process, so it's always fully automated, integrated into the pipelines. Especially nobody touches the production database in our DevOps solution. There is always a need to handle corner cases with custom migration script. There is no tool knowing about the business logic of your application, so there is always a need to inject, to add some custom script logic to your migration automation. And last but not least, as we have seen at the end, the database deployment could be packaged into your application, in your application package, as we did with Helm. It simplifies the pipeline, but again, if you're not able to do that, having the database deployment within your pipeline is fully okay. Thanks a lot for your attention. Thanks for listening, and see you next time.